So we're solving a differential equation, dy dx equals x root of x squared minus 16. So one way to do it without regarding it from the differential equations topic, but just regarding it as a straightforward integration, is to re-express this derivative as dy dx is equal to x brackets x squared minus 16 to the power of half. That would be a much easier looking question because it almost has the derivative of the internal function x squared minus 16. It almost has that sitting in front of it because the derivative of x squared minus 16 is 2x. So I could find the answer to that y is equal to the integral of 2x x squared minus 16 to the half dx, but I need to throw a half out the front just to compensate for the fact that I put an extra 2 there, so that there would be out the front of the brackets the derivative of the internal function sitting there. Now that's on the top of, that formula for that is on the top of page 3 of your formula sheet. So if you look on your formula sheet, integral calculus, page 3, up there on the top of the sheet there is the formula that I'm talking about, where the derivative of the function is sitting outside the function raised to some power, and the answer is 1 on n plus 1 f of x to the n plus 1 plus c. So let's go back now to our question that we're answering and work it out. So this will end up being a half, and then we've got 1 on n plus 1, so 1 on half plus 1, which is 3 over 2, and then f of x, which is our x squared minus 16, to the power of n plus 1, which is 3 over 2, and of course there'd be a plus c. So there's our value for y. Let's just make that a little bit simpler. A half and then 1 over 3 over 2. 1 over 3 over 2 is just 2/3. So that's really a half times 2/3 of x squared minus 16 to the 3 over 2 plus c. So our actual thing is 1/3 x squared minus 16 to the 3 over 2 plus c. Now they give us some values up here to substitute in, that when x is 5, y is 13. So let's substitute those in. 13 equals 1/3 5 squared minus 16 to the 3 on 2 plus c. So 13 equals 1/3. 25 minus 16 is 9. So 9 to the power of 3 on 2 plus c. Okay, so you can put that in the calculator, or it's the same as the square root of 9, which is 3, then cubed, is 27. 1/3, so 13 is 1/3 times 27 plus c. So 13 equals 9 plus c, so c is equal to 4. So my final answer would be that y is equal to 1/3 of x squared minus 16 to the 3 on 2 plus 4. And the question was asking us to solve that differential equation for x is bigger than or equal to 4. The reason is, if it's less, well, it's going to be an interesting situation trying to square root that. But that's kind of not relevant to us in our actual working out. We just needed these other values to work out our constant of integration. Now, another way to answer that might have been to use a substitution. So I'm just going to create myself a bit of room here, just erase some of this stuff I've drawn on here, and create a little bit of room to redo the question, but with substitution. Now, whenever we have something of this format, we're going to use u is equal to whatever the internal function is in the brackets that's being raised to a power. So I'm going to say I want to let u equal x squared minus 16. Therefore, du dx equals 2x. So du is 2x dx. So I'm ready to go now. I have dy dx is equal to x and then root of x squared minus 16. Now, I want to find y, which is the integral of x root x squared minus 16 dx. So let's just scroll down and give me some more room. I'll just get rid of some of this stuff that I've got in the way. Sorry about that. Now, I'm going to do my substitution. I know that u was x squared minus 16, so that's a root of u, and du equals 2x dx, so I've got x dx here, but I need 2x dx to be able to put a du, which means I've got to compensate by multiplying by a half. So, you know, if I wanted to set that up properly beforehand, I would have written that this is a half of 2x root x squared minus 16 dx, so that I could grab my 2x dx and replace it with a du, and then what's in the bracket under the square root sign could be replaced with u. So in the end, I'm trying to find the integral of a half of root u du, which is a half of the integral of u to the half du. So that's half times, and that's u to the 3 on 2, times 2/3. So I end up with a third u to the 3 on 2, of course, plus c. And I need to replace back in because I haven't got myself a definite integral. So it's a third, and then u is x squared minus 16 to the 3 on 2 plus c. And then we reached that stage before. In order to evaluate c, we need to use the values they've given us at the top here, when y is 13, x is 5. So because y is equal to that, 13 equals a third of 5 squared minus 16 to the 3 on 2 plus c. So we remember from before that that's 9 in the brackets. To the power of 3 on 2 is 27, times by a third is 9. So 13 is 9 plus c. So c equals 4. So our final answer, either way we did it, was a third x squared minus 16 to the 3 on 2 plus 4.